Welcome to This Explainer. Today, we're diving into one of the most fascinating technological whodunits to hit the AI space in recent years. We're going to methodically track the sudden appearance, the digital forensics, and the ultimate unmasking of a mystery AI model that literally took the developer world by storm. So, here's the situation. Back in August 2026, this completely unknown yet highly capable AI model just appeared out of thin air on developer leaderboards. No company name attached, no research paper, absolutely zero marketing budget. But get this, it offered a massive 1 million token context window entirely for free, and in just a single week, it processed a staggering 9.4 trillion tokens. We're going to look at exactly who was behind this, how they got caught, and why this specific model is probably going to change how you use and pay for AI in the near future.
Okay, let's dive into this. We've got a tight roadmap for today. We'll start with 1, the Ox Alpha mystery, then 2, tracing digital fingerprints, 3, unveiling GLM 5.3-Flash, 4, benchmarks and rock-bottom costs, 5, the open weight shift, and finally, 6, what happens next.
Section 1. The Ox Alpha Mystery. So how does a frontier-level model just appear anonymously? Well, it was simply listed on the OpenRouter platform under a stealth path as Ox Alpha, and it cost absolutely nothing to use. It offered a 1 million token context window, which, means you could feed it massive code bases or entire books all at once. And the sheer scale of its usage was just mind-boggling. Processing 9.44 trillion tokens in a week. That's not a weekend hobby project. The system actually claimed a capacity of 100 trillion tokens per day. Someone, somewhere, was footing a massive compute bill to run this in real, heavy-duty developer workflows, all while stubbornly hiding behind the label of an undisclosed organization. Let's find out who. Section 2. Tracing the digital fingerprints. Now, that kind of scale naturally attracts attention, right? When the front door is locked, you have to look for digital fingerprints. And a clever forensic investigation by a popular YouTube channel actually broke the case wide open. First, they analyzed the listing itself, which was completely barren, like no lab, no Hugging Face link, nothing. Second, they tried the obvious, just asking the model directly who it was. Well, the model replied with this hard-coded script, "I am Ox Alpha." It also had this strict artificial amnesia. If you asked it about anything past mid-2025, it comically played dumb. So asking it directly was totally useless. They had to move to step 3, fingerprinting the tokenizer. Tokenizer fingerprinting is such an ingenious investigative method. Think of a tokenizer as a model's digital DNA. It's basically how the model chops up text into readable pieces. If you send the exact same strange string of text, a mix of code, Chinese characters, some random emojis, to different models, they'll all chop it up slightly differently. That gives you different token counts. But models from the exact same family, they will process it the exact same way. So the investigator took these identical strings and sent them to 11 different models. The results were pretty stunning. Compared to a known model called GLM 5.3 from the AI lab Z.ai, Ox Alpha was exactly 75 tokens higher. Every single time. Not just close, exactly 75 tokens, whether the input was Hindi, C++ code, or just 200 blank spaces. That constant offset of 75 tokens represented a hidden system prompt. Out of 422 models tested, only Z.ai's specific GLM settings perfectly matched this digital fingerprint. Section 3. Unveiling GLM 5-3-Flash. And this brilliantly illustrates how impossible it is to truly hide a massive software system in today's interconnected ecosystem. Because shortly after the community cracked the code, Z.ai officially confirmed it. Ox Alpha was an anonymous stealth launch test for their new model, GLM 5.3-Flash. So that massive free week, it was actually a brilliantly disguised public load test. Z.ai was serving this preview on tens of thousands of domestically developed Chinese AI accelerators, really challenging Western tech dominance. They basically used the global developer community to stress test their architecture before officially releasing the weights to the public under an MIT license. To understand why this model could handle 9.4 trillion tokens for free, we have to look at its architecture. GLM 5.3-Flash uses a mixture of experts or MoE design. I kind of like to use a specialized team analogy for this. Imagine a massive company with hundreds of employees, but for any specific email that comes in, only a specific 18-person department is activated to handle it. The rest of the company just stays powered down, saving massive amounts of compute energy.
The absolutely crucial takeaway here is this number, 18 billion. See, GLM 5.3-Flash is a massive model overall, sitting at 320 billion total parameters. But because of that MOE design, only 18 billion are actually active for any given word. It's like getting the brainpower of a supercomputer for the running cost of a laptop.
Beyond just those active parameters, the model is packed with incredibly efficient design choices. It's natively multimodal, meaning you can feed it text, images, and video right out of the box. Combine that with that massive 1 million token context window we mentioned, and you've got a system designed to handle huge, complex coding tasks at a fraction of traditional computing costs. This is really thanks to hybrid attention mechanisms that slash compute by 3 times and memory needs by over 4 times compared to older models. Section 4, benchmarks and rock-bottom costs. So we know who made it, and we know how it's built. Now, what's really interesting about this slide is why it actually sent shockwaves through the industry. Look at this contamination-free data from LiveBench. A score alone doesn't tell you if a model is worth it, right? You have to weigh cost versus quality. Premium Western models like Claude Fable 5 and GPT 5.6 Sol score in the low 80s, but they cost around $1.43 and 51 cents per successful task, respectively. But then there's GLM 5.3 Flash. It scores a highly respectable 71.6, but costs just 3 cents per successful task. The gap in those profit margins is literally staggering. This visually reinforces how drastically Z.ai is undercutting traditional models. They're providing high-level reasoning, approaching those premium models on certain coding tasks for just a fraction of the price of their competitors. Section 5, the open weights shift. This dramatic price difference actually brings us to a larger macroeconomic story playing out in the AI ecosystem right now, the shift toward open weights. We're currently watching 2 very different distribution strategies battle it out. On one side, you have closed APIs. This is the model favored by Western labs like OpenAI and Anthropic, where the models are proprietary, access is strictly controlled, and you're paying a premium for a managed service. On the flip side, you have the open weights approach. Following in the legacy of disruptors like DeepSeek, Chinese labs like Z.ai are releasing highly capable models under permissive licenses. This lets developers anywhere download the weights, run them locally, or modify them entirely. The strategy of launching as a stealth mystery model on third-party routing networks, getting everyone hooked on that free performance, and then suddenly releasing the open weights, well, it's a highly calculated playbook. It completely circumvents traditional distribution bottlenecks, basically forcing rapid developer adoption. More importantly for us, it introduces massive competitive pressure that will likely drive down the prices of those expensive, closed APIs over time. Section 6. What happens next? So what's the ultimate takeaway from this whole OxAlpha investigation? What happens next? Well, the research firm Hyper.ai summed it up perfectly in their analysis of the launch. They noted the cumulative impact of these releases introduces measurable competitive pressure on frontier model providers, as cost-sensitive enterprise clients and independent developers increasingly prioritize accessible, open-weight architectures. What this tells us is that we're seeing a real, tangible shift towards distributed and modular model ecosystems, simply because the economics absolutely demand it. The mystery of OxAlpha was a lot of fun to unravel, for sure, but the model it left behind, GLM 5.3 Flash, is a serious tool with some very serious economic implications. It leaves us with a critical question to consider as this technology advances. Will the flood of hyper-efficient open-weight models truly democratize AI development for everyone? Or are we just seeing the opening battles of a new global war between open and closed AI? That's something we're going to be watching very closely. Thank you so much for joining me for this explainer.